Okay, hello everyone, and welcome to today's Orchestrator Weekly. We have a topic for today, and that's the Osd creation in the Ceph Orchestrator, with the various topics. Mainly how to get PVs into the Ceph Orchestrator, how to create OSDs on PVs using the Ceph Orchestrator, existing issues, and how do we deal with local persistent volumes versus PV versus claims? I don't know. I think it's up to you. Um, 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 Ankush, do you want to explain how you do that in OCS? And tell us briefly what you do, and maybe we can then try if we.
Okay, sure. Am I audible, question properly?
Yep, you are.
Yes.
Okay, sounds good. So my name is Ankush. I work on the UI aspect of the OCS, and yeah, I can briefly let you know how the OCS operator works, or what is the workflow from the UI perspective. Uh, of the OCS. And so starting from, as Sebastian was saying, how you create the PVs out of the local disk, and also after those PVs are created, then how do you create PVCs out of those PVs that can be consumed by the OCS applications. Uh, I think I'll just give a brief demo about it. I just created a setup some time back. Probably that will give a clearer picture to everyone on how this happens from the Openshift UI. So as you can all see right now, I hope,
Yep.
is it,
Yes.
yeah, okay. So this is the Openshift UI, and what I have done is I have installed the OCS operator, and I'm going to show you how you can create PVs out of the disks that are there, and out of on the top of those PVs, how you create the OSDs using the Rook operator internally, but the abstraction layer is OCS on top of it that does all that stuff. Uh, so I have,
Juniper, get out of there.
sorry.
Sage, you weren't
I got
muted.
my mute backwards. Sorry. Okay, getting
Okay,
muted.
Ankush, continue.
Okay. Uh, So yeah, so as you can all see that I am inside the OCS operator. The full form of the OCS is OpenShift Container Storage. And when I come to this page, it says me to create the storage cluster as the CR name for the custom resource name for the creating the storage. Basically, for the OCS cluster is storage cluster. So I'm going to click on it, and there are multiple options right now. One is internal, one is internal attached devices, and another is external. So just a brief introduction. Internal is used if you want to connect to your cloud provider using the cloud-based storage class name. As if you are an AWS setup, the cloud provider already provides you the storage class name as GP2. If you are on a VMware, it provides you the thin storage class. So if you want to use that workflow, you can use this internal workflow. But if you are on a bare metal system, which is a use case from the Ceph perspective or the Ceph orchestrator perspective that I'm going to briefly show you today, we can click on this mode, and you can see we have a 5-step wizard flow. What this 5-step does is, first step is where you discover all the disk on the node. So but by default, there is no job running on the disk that gets you discover all the nodes. So because of there are some resource constraints, that if there are like 1,000 nodes, they cannot run the job on all the 1,000 nodes and discover a disk for you. So what LSO perspective is that they want you to select the nodes on which you want to run this discovery, right? So I can select particular nodes, or I can say all the nodes I want to select all the nodes. I just want to take questions if there are any confusion until this step.
Not yet. Nope. Thanks.
Okay. Okay, sounds good. So I'm going ahead and clicking on next. By clicking on next, you can see that I have 3 nodes available and 3 disks are available with me. If I click on this, you can see that each of the node is having 1 disk available that is of 100 gig of capacity. So that's what I'm going to use. This is the local volume set name that I'm going to provide. I'm going to say demo, and there are filters provided by the local storage operator. So you can either say what kind of volume mode you want, block or file system. You want to select the disk or you want to select the partition. You can unselect it and you will see that this capacity donut shows 0 capacity over there. So I can put it back and you will see that the selection is made. Also, you can put the minimum and the maximum disk. So if I put 101 gigs, it will get unselected. But if I back and say the minimum size to 1, it will get selected. So I'm not going into deep into that. And I'm going to say next and create me a storage class. What in the background this is doing is that this is creating a storage class for me, and on top of the disks that were available with me, the 3 disks that were there you saw, it is creating the PVs on top of those 3 disks that are there. Till now, there are no nodes found. Basically, there are no PVs that are created on that. It takes around a minute or so for this process to complete. So at the end of this flow, the PVs will be created on top of the disk that were there. I am idly going to wait for 30 more seconds probably until the time I see the disk over there. This view has been updated now, and in the 4.9, the version that is coming now, you will see a loading screen over there that will say how many PVs are created out of the disk. So sorry for the UX flows over there. Is there any questions? I can take it up because we have like 15 or 20 seconds more.
I just wanted to mention that so in the background, this creates a local volume set object that will continue to match PVs with devices with this criteria and create PVs. It's not just a one-off operation.
Right. Okay.
Yeah. So from the UI there is a abstraction that we have done. So we are ideally, as Rohan mentioned, we are using 2 or 3 different CRs. One is LSO based discovery. Second is creation of the storage class using the local volume set, and another one is basically the storage clusters CR creation that we are doing. So everything is abstracted behind the UI. And now you can see that we have the available capacity of 300 gigs, and we are going to create 3-way replica. So this is the total available capacity that is going to be with the user. And these are the disks that on which these are the nodes that on which the disks are there. So I'm going to go ahead and click on next. You can basically OCS provides the encryption functionality, so I'm not going to go deep into that. And at the end of the step 5, you will see that 3 nodes are selected. The CPU or the memory is not enough. I'm not going to go into that because I have not created big enough nodes. But that is like the workflow. If I click on create, all the pods will start coming on the on those nodes, and the OSD will be created. And at the I think it will take 5 minutes for the OCS cluster to be created at the end of this process.
Okay, so just to summarize, those first 3 sets or steps were basically deploying the LSO operator and creating the storage device set discovery, whatever it's called, the discovery object, telling it to discover PVs for all nodes. And then the last step, or whatever, when you deploy Rook itself, you specify a device set with the storage class of whatever the class was you just created, and you set the count to however many devices you counted.
Yes, right? Exactly. Exactly, okay. Yeah.
Okay. Okay. Maybe it'd be helpful to like just frame what the high level goals are for this. because we've like gone around in circles because there's so many different like ways to approach this. So first of all, the goal is for whenever we deploy Rook, we want to use PVs exclusively. We don't want to have to make use of the bare metal support in Rook. So we want to use LSO or some other operator that lets us bind to a PV so that there's some transparency to what devices we're using. And we also, I think LSO is what we're looking at right now, but I think ideally we want to make sure the door is open to other sources of PVs. So like maybe if there are manually created PVs and source classes, like it'd be nice to be able to consume that in whatever form we can, or if there are other dynamic provisioners like EBS, obviously we want to support that too in the way that we integrate this with the rest of the Ceph manager module. But at the same time, we want to be able to show the user like information about the bare metal device, like it's which host it's attached to, what the device path is, what the vendor is, what the serial number is, all that stuff, which is only going to be available sometimes, I guess. So it also provides that information through the discovery result, but other PV provisioners might not. So we want to at least have one recommended path or something that will give you like a full view of. Sorry, one sec. All right, sorry. Like logistical issues this morning. Right. So, I mean, what we want to be able to do is through the Ceph interfaces see like these are the hosts, these are the bare metal devices that are attached to them, and be able to create hosties on those devices. And obviously, just having like manually created PVs doesn't really do that because you can't tell what the device model is or serial, or you don't know what kind it is. All you really see is the PV size and name, which probably isn't going to tell you much. But in the case of LSO, you have this discovery thing. So that's good.
Right, one question, Sage.
Yeah.
So how specific are you hoping to be with allowing the user to say, I want an OSD on this device and that device based on serial number or really specific details, right? You're hoping to be granular like that?
Yes. Yeah. So the derived groups support all these filters that let you filter based on like the model or the serial number or the path or the size, a bunch of stuff. It's more selective than what is possible with Kubernetes labels. And so what that's sort of pushing us towards is even if all the labels were present on the PVs, I think the PVC label selection filtering stuff is not sufficient to like express what the drive groups can do. So I think what should happen instead is the implementation in either Rook or the manager module. I don't think it matters which one. We'll basically look at the available devices, look at the drive group, do its own matching, and say, oh, I want to create an OSD on like this particular device that matches these criteria, and then go tell Rook to go create that particular OSD, and then repeat the process. The problem with that, so on the LSO side, we have a bunch of sort of minor gaps that prevent us from being able to do that. So there's the discovery result, which has a dump of all the metadata about the devices, but there's no unique identifier for a device except the device ID, which is only sometimes populated. So it's not actually unique. It's like on a VM, it's just blank. So that's sort of the first problem. The second problem is there's nothing on there, or maybe it's the same problem. There's nothing in the discovery result that would let you create a PVC that will bind to that particular device. If you go look at the PVs, they have a name identifier, and you can bind a PVC to a particular PV name, but that name isn't included in the discovery result. And if you go and I think the only thing you can currently do is you could get the discovery result, then you can also go enumerate all the PVs and manually like match up the hosts and the paths between the two. And then and the PV has a name, and then you can have a PVC that matches to the name, but it's like super annoying. I'm wondering if there's a technical reason why there's no identifier in the discovery result that we can just directly use, or is that just a fact of life that we have to go through that extra step?
I can bring up the option of including the PV identifier in the discovery result next time I meet with the LSO team.
That would be excellent. That would just save us a bunch of back spending.
Santosh?
Yeah. I was distracted.
You're not really audible here.
Sorry, just give me a second.
Like you're in a barrel.
Yeah, am I audible now?
That's better, yes.
Much.
Yeah. Rowan, can you say that again? I was distracted.
Hey, I was just saying that we could discuss it with the LSO team, whether we can include the PV identifier in the discovery results.
Okay, yeah.
Yeah, that could be, we could just converge the discovery daemon and the disk maker daemon, and that would make it much easier.
Okay.
Okay. Yep. Okay. Yep. I think that would solve that part of the problem. Oh yeah, Joseph.
So at the moment, the deal is that there's no like unique device ID if a disk doesn't have a serial number. So the issue is that in the VM, like the disks that I was attaching were like virtual disks, and they didn't have a serial number. So if the serial number for a disk is missing, there's no like unique device ID. But if there is one, then there will be a unique device ID. But I think like the PV, the discovery result, the PV thing should still like happen.
Yeah. So I think if the PV is created, it has a name, and the name is unique. And so if that were included in the discovery result, I think that would be sufficient. Yeah. And the device ID is like kind of yeah. I don't know that we need it actually directly.
If the device ID is not available though, the PV that the LSO creates, it's based on the device name, which it's not stable.
Yeah. Yep. Which I think that's just a fact of life, right? There's no real technical way around that. Yeah. What does LSO do if the device like disappears after a reboot or something like that? Or just a refresh and the device goes away? Does it go to delete the PV?
At the moment, it does nothing. I think Santosh is working on some metrics that will alert the user if that happens.
Yeah. Okay. 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 Well, I think in any case, closing that gap, I think will solve that part of the problem. Which sort of brings us back to the bigger questions about like who's responsible for what. So for OCS operator and the dashboard workflow that you guys just showed, I think that makes perfect sense for OCS where it's like it's all in one. But for Rook itself, I'm not sure that we want Rook to be responsible for deploying LSO or Ceph to be responsible for deploying LSO, because I don't think it seems like we shouldn't be opinionated about what you have to use. We should take advantage of something that's smart if it's there, but we should fall back to some like reasonable behavior if we don't. So I'm wondering if then, if we want to have like in the Rook examples directory where all those YAMLs that you're usually pasting in to like create the operator, create all the RBAC stuff, whatever, there'd be one in there that's like deploy LSO. That it has like a default CR that discovers all devices on all hosts. Creates a storage class called like local or something like that. And then, or something, I don't know. I'm not quite sure what we want, what we want the end user workflow to be. Yeah.
For this stage, we're actually looking at consuming LSO as a library instead of deploying it. So we're really hoping to get what we have from the Rook discovery and then include some of the like nifty, I guess, that we get on LSO instead of having to deploy it. So I've run into a small prototype today. I'll work a bit more on it tomorrow, but right now, that's where we are. We spent some time with Travis and Ron discussing this earlier. And my goal is really to get this working this way. Not having Rook deploying LSO because we never going to do this, but really consuming the most relevant piece of LSO as a library coming from Rook instead.
Does that mean that like the same functional pieces would be there? Like there'd still be a storage class and there would still be PVs?
You will still get PVs, you will still get a discovery, you won't be getting a CR out of it because you won't have the LSO operator running the discovery and then creating CRs for the results. So you will get something that is a little bit different, but ultimately the workflow should be quite similar. It's still like under like heavy design. My brain is sort of melted right now because we spent like really an hour discussing all the options with Travis, but we still need to discuss that a little bit more. But I feel like we're kind of on board with the idea, and it feels like the right path for us to move forward, which should kind of simplify also our transition from the old-fashioned way of deploying on bare metal versus the all-on-PVC setup, even if you run bare metal. So yeah, that's where we are. And I guess this is also some kind of a warning as like, don't go too far into some of the LSO details, because like if we shift gears a bit on Rook, that's why we.
Well, I mean, that sort of makes me wonder if what we really want to do is if we get away from looking at the LSO discovery result and instead just enumerate PVs. Like if LSO just put all of the information in the discovery result as annotations on the PVs, like the vendor model serial, all that stuff was, if all that stuff was there, then from the Rook or the manager Rook Ceph perspective, you could just say like, this is the storage class to look at for local devices. And we could, and then we can show whatever information we see and understand. Because if that were the case, then regardless of whether you deploy LSO manually and it creates those PVs and you point it at the right storage class, or you embed it as a library and you end up with those same PVs, there would just be one storage class where we just list all the PVs, and that would be the stuff that we'd show in like Orch device LS.
I guess I'm still a bit confused. Like, are you looking at getting a list of PVs or a list of devices that will ultimately become PVs that you can consume?
I would say devices. I'm kind of equating the two, I guess, right now. And maybe that's part of the problem. Because I'm thinking about just like the simplest case, because I'm not quite sure how we're going to deal with partitions and stuff.
We kind of have it already. So I think for now it's more like, how do we present it? Because today you're looking at a CR, but could be a config map, could be something else. But yeah, go on, Travis.
Yeah, I was going to say, I think we want to discover devices, and then after we know where the user wants to create OSDs, then we create PVs on those devices.
Based on the builders that we have applied. So it's like a 4 steps decoupled. But yeah.
Let me ask a question.
Okay.
The OCP UI, workflow that we saw. I mean, why would it have to be any different from a workflow perspective? And what are we missing there? That based on the conversation, I know we don't have OCS, so we're going to have to do something else to do some of the automation for that workflow. But is there any reason we wouldn't have that same look and feel on the dashboard from a high-level UI perspective? I mean,
I think the constraint is more around like upstream versus downstream. Upstream, there is no OCS. There is nothing that will deploy other operators for you.
Understood. But devoid of that, I mean, looking at the workflow, is there any reason we couldn't re-implement that same workflow that you saw from an OCP UI perspective? Is that adequate? What is lacking from there? And why wouldn't we do something very similar?
I think
it's the overall experience. It's the overall experience as well. Like we want to drive everything from Rook and Ceph, where if you have LSO in the picture, then it's like yet another component that you have to deploy and maintain. It's like this like really large prerequisites that we don't think we really want to have. being included. Does that make sense for you, Jeff?
Well, if again, I think you want to, be less prescriptive in this world, having to know what those devices are and controlling those devices, I mean, is going to be a requirement. So, no, we'll have to work out, I think the workflow is what you want and, make sure that it's implementable. I mean, so I'd love to see it similar to what we just saw, if we can. And, I just don't get the subtleties of why it can't be, I guess. So.
Well, honestly, I guess I'll just put it differently. If we had what I just described, like the wish, the goal, the workflow would be much simpler downstream. We wouldn't have to go through 3 pages to select all devices and things like this. This could be much easier. But that's the way we have it right now, just because of timelines and everything. And I think what we're discussing right now is not to change how we do it downstream, because that's likely going to stay that way. Like migrating from what we have today to what we are aiming for tomorrow would be just like disaster. So I think it would just stay on. It's just that we have to. Yeah, I know you like this, but it's like purely upstream at this point. With this one, it's like Rook has to come up with an alternative or something default to bring an experience over PVs, regardless if you run on dynamic environments like cloud or if you run on bare metal. That's why it's not so much touching the downstream use case.
But at the end of the day, the upstream does have to support some alternative that we can use downstream. We don't want to have some one-off thing downstream, right? I mean, so.
Oh no, I fully agree. I fully agree, and I think this is just bad timing, honestly, that we have that current workflow. And don't get me wrong, I wish we could like really homogenize what we want to work on upstream and ultimately have that implemented downstream.
Now, at the end of the day, if we need something like LSO upstream, but LSO really isn't upstream, it's only a downstream thing, correct? I mean, why aren't we endorsing something, from a upstream perspective that will give us that functionality? I mean, do we need that?
When you say endorse, do you is that bringing a community around LSO for upstream? Is that?
Yeah, I mean,
honestly, and this is just me, I guess. I'm kind of not a big fan of the build a new operator for anything and everything. And I really think that what we're trying to do right now should be in Rook and could have been in Rook from the very beginning. And we have to stop that pattern at one point. Oh, I want to do something. Okay, let's write a new operator. No. There are things that could be controlled by existing operators, and I think that is one thing.
But another, I guess, a counterpoint to that would be if every storage vendor, I mean, and local storage being one of them, has to have its own operator, I think, because eventually you're going to need to converge with other solutions upstream, and that might even prevent Rook from co-locating with other upstream providers of local storage. And a lot of things are happening in CSI. Eventually, local volumes, I think, would have to move to CSI.
Sorry.
Yeah, I think I was done.
I mean, the thing that concerns me is that it seems like the management of the hardware devices on the nodes needs to be somewhat separable from Rook, because you're going to have you may have consumers of those devices that aren't Rook. So you might have Rook consuming half the devices on the node, and then other devices are being consumed directly by pods or whatever else. right? I don't
Yeah,
know.
but
I don't know
it's
if
not
I'm
because
fighting LSO.
it's not
One
because
thing.
you can manage PVs through Rook that it's kind of colliding with other LSO-ish solutions.
Sorry, say that again.
Sorry, can you repeat?
I said that it's not because we could have this embedded in Rook that it means it will collide with existing solutions like LSO, for example. Both could just like coexist.
Yeah.
If Rook
Well,
claims
right.
a device, how do we know that LSO has? I mean, how do they prevent
Yeah.
from going? How would we prevent them from conflicting?
But you have code for this already. The one we just
But that
discussed
looks
earlier,
at
like we.
that looks at
But
very
okay.
LSO specific things.
Yeah, but I guess like any, it's not like LSO is like super standard anyways. Like there are other local storage operators
Yeah.
out there too. It's not like we're so biased because we read it, but there are also other operators too. That's also a counter argument. But I lost track. But
yeah, I guess
there,
that's
like even within LSO, like if you inject multiple CRs, what's the guarantee that some PVCs won't be picked up and everything? And we already like discussed that topic, I think, and we also had that issue, right? But yeah.
Sorry, like I mean, LSO, two LSO PVs won't use the same device. It could pick up something that's used by something else, but it does have a bunch of checks for that.
Okay. I thought about a discovery that at some point we were discussing things like if you run two discoveries, they could pick up the same devices and get like PPs, and maybe that's why we have the locking in place now. So okay, never mind.
I mean, I guess this whole problem area is why I was sort of assuming that making the way that we interface with PVs or devices as generic as possible, so that we can consume PVs from any storage class, not just specifically the LSO one. But if it is LSO or some other operator that we are familiar with, we can look at the annotations to present the user with as much information as we can find. Right. So if you had, I mean, I don't know what the alternatives to LSO are. I mean, maybe it would be helpful to know what those are so that we have some sense of what else we might want to support. I know there's.
There is the Toulouse one. I always forget what the name is.
OpenEBS, I guess. Joseph, you said OpenEBS has one that generates PVs for local devices. That might be something that we want to.
And Topo LVM.
Topo LVM, yeah.
So yeah, would we want to present the available options to the user, or just the user provides a rule that says consume all of these that match this criteria?
One thought is it seems that probably the problem that we have in the orchestrator is that what if we decide to use LSO we are going to have a decision, okay, and to force to use one specific thing, okay. So maybe probably we should include or create a new interface in the orchestrator in order to get the information of physical devices. And this interface to have the possibility to communicate with different kind of operators, for example, LSAO or another one, okay, in order to get this information. And then we can use this information in order to create, for example, an storage class, and use this storage class in order to create PVs and provide these PVs to Rook in order to create the OSDs. Way I think that we are more independent of the final piece that is getting the information from the hardware, okay, and it's a solution that I think that we can use in upstream.
I mean, that's kind of where we're at right now. Like the Orchestrator already has an interface for physical devices. Like that's the only interface that's there. What's missing is a dynamic one. But what I was leaning toward was basically the manager work module. You would tell it what storage class to look at, or maybe a list of storage classes. And it could just go, okay, this is the storage class. I'm going to go enumerate PVs for that storage class, and those are the devices that I'm going to show the user. And if it happens to be an LSO storage class, then all these annotations will be present on those PVs, and we can show all the nice metadata about the physical device. But if it's not, if it's like, say the user just manually created PVs for whatever devices they have and dumped them in a storage class, then it would just show them with their size and like no other information, and we could still consume them. Like that seems like the sort of the simplest model.
that would lock in LSO as the way to go. And I don't know if
it would.
Ready for that.
I mean, it wouldn't in the sense that you could give it any storage class from any. I mean, you could give it a topo LVM storage class, or you could give it a storage class where you manually created PVs. Like any of them would work. You just might not see all the metadata about the device. But if it says, oh, it is LSO, then I can show you all this stuff. Maybe if it's an OpenEBS PV, then we can add support to do whatever introspection we need to do in order to show that information for those PVs as well. Like you could add support for other understood storage classes down the line.
Yeah, Rohan, how do we know it's an LSO storage class? Because I thought the provisioner was always the same when you do local PVs. That Kubernetes.io/no provisioner. So it's always the same, right?
You can look at the owner kind label. It will say local volume set or local volume.
Okay.
Yeah. Or you could just look for whatever annotations LSO puts there, and if they're there, you're like, great, I know what the vendor is. And if they're not, then
yeah, okay.
I think being vendor specific or being opinionated about one of them, I think I feel like it's the only way to go, because we're never going to have a general solution that works for all of them. So
yeah, I mean, you're never going to have a general solution that works with all features for all of them.
Right.
But you can have a general solution that will have like the very minimum always work.
Right, and be optimized like, for others.
Yeah.
Like LSO.
Yeah.
Yeah.
So Joseph,
so
you have something?
Yeah. Sorry. Go ahead.
Yeah. Sorry. Just quickly. Like for example, with OpenEBS, the way LSO works is that it creates like a storage class and then also creates like PVs and adds them to that storage class. The way OpenEBS works is that it doesn't actually create any PVs like preemptively. It only creates PVs when you actually make a PVC, and then it'll actually go and create the PV, which is how I think it's supposed to work. So for example, like if you try to use Ceph org device ls and you're looking at PVs and you're using OpenEBS, there's no PVs until you actually consume.
The dynamic provisioning approach.
Yeah. So, I mean, I guess maybe then the way that the code would work is it would look at the storage class that you told it to look at, and it would say, oh, this is an LSO storage class. I'm going to do the LSO way to enumerate devices. And if it's an OpenEBS storage class, it'll do the OpenEBS way. And if I don't understand the storage class at all, it's just unknown to me, then I'll just list PVs.
Why do you need to enumerate devices? What do you need to enumerate devices?
So the Ceph Orch device ls command works, so the user can just see what devices are on their nodes in the dashboard. When you say like, I have a cluster, like what do I have? Are there disks on these nodes? What is the inventory?
Oh, right. Oh, okay.
Like with OpenEBS, can you discover what's there, or it's just the dynamic provisioning?
There's like a way of doing it. They have their own CRs, which is for every like device that you have, there's like a block device custom resource that I think like has some metadata about that device. I didn't look too deep into it, but there is a way of like getting
mode.
Yeah. I think it does like discovery automatically. And it's like it does discovery on like all nodes that it's running on for all devices. There's no like filters or anything.
And
it's
CSI
different.
recently added a capacity interface, so they might report that also if they're using CSI.
Yeah. mean, we're talking about LSO and OpenEBS, but I think like another goal here would be, I mean, one goal is to just have some fallback behavior that'll work in like weird environments that we don't know about. And I think that the simplest would be like the user manually creating a storage class and manually creating PVs, which happens to be what Toothology does because it already has a disk carved up into LVs, and we want to just consume those PVs as separate devices. So I think that's actually like a nice implicit target or whatever to be able to support that as well.
I feel like there is like two. I think the reason why I ask why do you need to enumerate is that I don't think you really need to enumerate drives. But if you really want to, then we can run a discovery pod, just like we do with the Rook discovery. And you can see all the devices on all the nodes. But assuming that you have path labels, you select which nodes.
I mean, for a human that's operating a cluster, like they have to be able to see what's there in order to.
That's possible. I'm not saying it's not possible.
Okay.
It is possible.
Yeah.
But by the time you're bootstrapping the cluster, then you will be enumerating the filters like that you want. Either you want to take all the drives or say, okay, yeah. I know like I have Samsung drives though, so give me Samsung drives. They are like 1 terabyte each. But these these are two different things. Like because you can live without the enumeration, but and only have the part where you do the filtering and the deployment goes on. Search for all the devices, goes on through the nodes you wanted to go on, and bootstrap whatever you wanted to bootstrap.
I think you need. I think you need the enumeration though in order to do the filtering because the filtering selection stuff that PVCs do isn't sufficiently general. Like it doesn't have wildcards and whatever. It doesn't have
and I guess what I'm saying is that the discovery doesn't have to be part of LSO or Rook, but it can be like, for example, Rook has a discovery thing already that can be used. And once we kick it off, then we report for each node what are the disks and why they are available to.
But the problem with the Rook discovery is that it's not related in any way to PVs that you're eventually going to consume. So you can't map the Rook discovery back to LSO PVs or to OpenEBS PVs or.
No, but once you get the list of disks you want to provision, you just tell Rook, and Rook can go ahead and by using LSO as a library, create the PVs and also create the storage class at the same time too, and then gives you the cluster you asked for.
That works in sort of a vacuum if you're just using Rook, but it doesn't work in the case where you want other people to be able to consume local storage as well. And you already have an operator to do that, right?
So then you just need to pass the name of the storage class.
Right.
And then you can still use the same template. Because at this point you're assuming that you have PVs, right?
Yeah, I mean, as soon as you have an arbitrary storage class that isn't controlled by Rook, then Rook can't create PVs because it doesn't know that it's going to like step on somebody's toes.
No, but it doesn't have to. It would just go and create PVCs then if you give it a storage class, just like it does when it deploys on the cloud. And if you have already provisioned local PVs, then everything works.
Right, but that's brings us back to where we started though. Like if you have an existing storage class, then you need to be able to enumerate the devices so you know which PV to consume with the PVs, so you can apply the drive group filters and all that stuff. Like the discovery doesn't help if you have an external storage class. You still need to solve this problem.
Because you don't know what to look for. You don't know what to look for.
And you don't know how to relate the two things together. Like it feels like we should focus on the case where there is a storage class, and it seems inevitable that we have to support the case where there's an external storage class managed by somebody else, and we're sort of forced into a world where those storage classes are going to be managed differently. Like they might be an LSO storage class, it might be a user managed storage class, it might be OpenVBS, it might be something else. And so we're going to have to like think of them in different ways, unless we are like 100% opinionated. It only works with LSO, but I think that's not going to fly.
Right, and ultimately, so Rook until today has assumed that we don't create PVs. We just say, oh, something else is going to deal with those PVs, and we'll just consume them. But I think the question that Seb and I were kind of trying to discuss the last few days in detail is like, wait, can Rook actually become a creator of the PVs and manage that whole life cycle so that we can get a better integrated experience? And I feel like even after all those discussions, to some degree, it still feels like, well, could we really use LSO as a library, or does it really need to be a separate operator? I still don't feel clear on that.
Yeah.
On that answer.
I guess my concern is that if it's not independent, then other people can't really consume it. Otherwise, you're forced in this case where like you're deploying Rook just to expose local devices that other things consume. I don't know. I mean, it feels like they should be separable, because you're gonna, over the life cycle of a cluster, even you might like change your mind about whether you're consuming the local devices directly or you're consuming them with Rook or whatever. Like it, right. I don't know.
Because Rook's purpose is only to create PVs to put OSDs on them. That's all we really want to do.
And you could have like one YAML file in the examples directory that deploys LSO along with the CR that discovers on every node, like the storage class is called local. Like it could just be like one kubectl apply done, and you can make it easy to like deploy Rook in that case. Because I mean, the goal that you're sort of driving towards there is like a simple out-of-box experience for Rook, where it can consume OSDs in the PV way, and it all just works. And it feels like you could do that with just deploying LSO in an opinionated way. One extra step in the process.
Right. Just LSO as a dependency basically would solve that, but it's less.
And if you don't want to use LSO, you could have an OpenEBS YAML file too that does the same thing. Like OpenEBS has the same basic function.
Yeah, but it doesn't. Joseph said that you don't get the PVs out of it because they only get for created.
Yeah, I mean it works differently. Yeah, right. But I think we're
so you see that even like not like using LSO as a starting point is also somehow being opinionated on how we want to base our design on. Where like other local storage operators have their own design, and so the design we're trying to make up right now doesn't really match with. It doesn't match with OpenEBS, for example. So.
Well, it could, right? So my high-level suggestion is that there's like one basically configurable, and that's that this is the storage class for local devices. And then you have the code when you want to get an inventory, you look at the storage class, look what type it is, and then you invoke some like bespoke method based on that and with some basic fallback, right? So
we are running a bit out of time.
Yeah.
So we can either use the remaining 9 minutes to continue discussing about how to use LSO, or we can try to come up with something that we can actually do as action items.
I mean, I guess at a high level, the fundamental problem is there isn't a standard way to deal with local hardware in Kubernetes, right? Like there isn't a standard for LSO or for whatever. And so I think no matter what, we're going to be in a situation where we have to like support multiple methods, write code to support like the most common methods with some sane fallback. Yeah. Because we can't.
Yeah, but it feels like we're working on the 10%, right? I think right now.
With LSO, you mean, or?
No, like overall for the design, looks like we're really targeting the 10% exception that we're gonna get. and not really trying to make it working for 90% of the use cases.
What's the 90? Which is the 10 and which is the 90%?
Well, the 10 is when we think about all the corner cases, like, and the 90% is like, okay, we can get something done working.
Right.
We're like, and we know that 90% of the users, for example, if it's Rook, are going to go with the, let's say, the local provider of Rook for storage by using LSO as a library. And maybe 10% of the time, you will get someone that has its own local storage operator no one knows about, and they don't know how to use it with Rook or with anything else. And then in that case, then we can like come up with suggestions, I guess. I think all of that is to say that the design we're hoping to get is really based on LSO, which is not maybe the right one. Just like you said, there is no standard to manage storage with Kubernetes, and it's not because LSO has one thing that it's necessarily the right one, and we might just be biased because it is the way where Red Hat does it today.
Yeah.
Well, okay,
I mean,
we
we
need
just
to
have
schedule, I guess, another discussion for this one, and we have to pick something, I know, because we can keep discussing forever, I think.
Yeah. Well, what if we go away and we write like a more concrete proposal for how it would fit together? And then we can have a separate concrete proposal. Because I'm curious, I don't really understand how the LSO embedding plan would work. I don't know if you guys wrote anything down, but that would be, maybe we can compare to that. Yeah.
Yeah, not yet. I need to run more experiments for this.
Yeah.
I guess I'll keep thinking on the use case where we don't know the PVs based out of the storage class.
Yeah.
Because if we can accommodate this, then, well, assuming this is only true for bare metal, not cloud, because you never know, it's dynamically provisioned. You have a limited capacity.
Yeah.
And what if we end up needing some sort of monitoring feature that comes up in CSI, and then Rook would have to implement CSI-based PVs, local PVs.
Yeah, if this happens to become a reality at some point, then yeah, Rook would definitely go and integrate with it, just like it does for the Ceph CSI and upcoming Ceph Cozy. Because that will be a standard. So we would definitely integrate with it. That will be the standard we're looking for.
Okay.
Okay. I have a quick unrelated question for LSO. What happens if you have a device that has partitions on it? Do you see PVs for both the total device and for the partitions? Or do you
we just the child partitions. If partitions are enabled in the inclusion spec, but if a device has child partitions, we never pick up the parent.
I see. Okay. And if you already picked up the parent and then somebody behind the scenes goes and create a child partition, then nothing happens.
Yeah, okay. Once the PV is created, there's not much we do.
Okay. Okay.
I guess we could emit like an alert or a metric.
Yeah, I mean, it almost makes me wonder if the OpenEBS approach where they create the PVs dynamically based on the PV and maintain their inventory separate makes. But yeah, you end up with this like every operator has a bespoke method of like representing what the inventory looks like. Yeah, okay.
Yeah,
Okay.
I guess if we want to get something into the standard, it goes into CSI.
Okay.
All right.
I have the slight impression that we will not come to a
No.
conclusion today.
Yeah, quick question, I guess, just real quick. So you said like a list of drives, but how do we know again which hosts we should be looking at? Or do we know at all? Are we expecting?
I don't know.
Because today we get one CR out of the discovery, and it's one CR per host. So I guess that's why we know how many hosts we have, right? That's the current assumption too. Is that right?
Yes, there is only one CR that we can create in discovery.
Yeah, but it's not so much of an LSO question. I guess it was more for Sage or Joseph on how the orchestrator interface would know how many hosts are available.
Yeah, right now it doesn't have anything. It doesn't have any awareness of that. That's sort of.
Okay. So it's just by reading the CRs or getting out of each nodes, we know how many nodes we have.
Yeah, I'm not even sure how the Orchestrator. Well, the Orchestrator has a get hosts, a thing that enumerates hosts. I'm not sure what the current implementation doesn't tell you everything.
That looks at the Kubernetes hosts.
Oh, all Kubernetes hosts, the whole cluster.
Yep.
Okay.
It is returning all the hosts in the cluster.
Oh, okay.
Is that a bad idea?
Okay. No, it's just like I'm just thinking out loud, I guess. But yeah, if we like if we look at all the hosts, then we might be looking for hosts that are not storage hosts. So we might have to be a bit more accurate on the list of hosts we're looking at, I guess, or looking into. Because if you get all the hosts, then it's
yeah, that's another part of the Rook manager Rook orchestrator interface that we need to like understand better. Because there's also a labeling scheme that the orchestrator understands that isn't mapped properly onto Kubernetes and back. So that you can like label which nodes get monitors or whatever it is.
Yeah, because really the entry point, regardless if it's Rook or OCS, is the node label.
Yeah.
So and label is like storage node label, for example, and then you really get the list of hosts that will be becoming storage nodes.
Yeah. Yeah.
That is also, I think, a big question mark. Right.
Yeah.
Okay, folks, we are out of time.
Yeah, Rook community is running soon, so whoever is interested.
Yep.
All right.
Thank you for joining.
All
right. Thanks, everyone.
Yeah. Thanks. Bye.
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 Thanks.